Hi guys, it's been a minute since I've made a video, but today I'm back and we're doing a dynamic programming problem. This is our first dynamic programming problem actually. We're doing house robber today. So we are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed, and the only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. So they say, given an integer array called nums representing the amount of money of each house, they want us to return the maximum amount of money that we can rob tonight without alerting the police. So in example 1, we're given this input array nums is this, and we would output 4, and they say we would rob house 1 getting 1 money, and then rob house 3 to get 3 money for a total of 4, because 1 plus 3 is 4. And then in example 2, we are given this input array nums, and we would output 12 because we would rob house 1, which gives us 2 money, rob house 3, which gives us 9 money, and then rob house 5, which gives us 1 money. So in total, this is 12 money. So before I jump into the code, let's do a few sort of like pre-planning steps for our algorithm here. So I'm gonna do this like up above maybe. So first we want to define like what is actually our solution. Like what does it actually mean? You know what I mean? So like we're traversing through the array obviously, and then for each element that we visit here, like we can call it index I, then what is the optimal value at each index I that we are visiting, right? So we can just call this like opt at I, and we'll say opt at I in this case will denote, so opt at I denotes the maximum amount of money that can be robbed from houses 0 to I. Right, so like if I is 0, we're at index 0 here, the maximum amount of money that can be robbed from index 0 is 1, right? Because we can either not rob, so our options are either not rob it, which we would get 0, or we can rob it, and then we would get 1. So obviously we're going to rob it here. At index 1, so like at this house here, we can, at this point we can only rob this one or this one because we cannot do 2 adjacent ones. And I'll get to that in a second, but the maximum amount of money we can rob here is the house before it or this one, because we can't do both, right? And so we can either rob this one and get 1 or this one and get 2. And so at this one, the optimal move is going to be to rob this one, because then we'll get 2. Until we get to 3, and then we'll realize that actually it's more optimal to do this one at house 3, or 0, 1, 2 at house 2 or whatever, right? Because our options are, because we can only do adjacent ones, we can either rob both of these or we can rob this one. And so obviously if we rob both of these, we'll get more because 1 plus 3 is 4 and this is just 2. So it'll be better for us to rob these 2. And like so on, right? So like that's just kind of the general idea. But this is sort of like the solution that we are trying to get out of this, right? Because they tell us here that they want us to return the maximum amount of money we can rob without alerting the police. So the solution is going to be opt of n, basically, right? Like where n, or n minus 1, I guess, where it's like the last element here. Not here, but like, you know what I mean? Like in our opt array or whatever. So yeah, because I guess we'll just like store the optimal value in whatever array we create, which is going to be like opt or whatever, and each index will correspond to the optimal amount of money that we can get from the same index of like the same house from here, if that makes sense. So the next thing we want to do is we want to establish our recurrence and our base case. So our base case, we'll start there. Opt at 0 is going to be well, okay, if we're doing it 0 indexed like this, then opt at 0 is just going to be the value that is in the first house, because that's the amount that can be robbed from there. So like in this case it would be like nums at 0. But I guess another thing is like if our array is 0, then we would return 0, right? Okay, and then at 1, then our only options are maximum of the 0th element and the first element. So sort of like the same idea. Opt at 1 is max of 0 and 1, right? Okay, now we can get into our actual recurrence. So at every single step I, besides our base case obviously, we have two options, right? We have either well, I guess technically even in our base case, but like we can either choose to rob the house, or we can choose to not rob the house at each index I. So like let's say I is 2. So at index 2, we can either choose to rob this house, or we can choose to not rob it and skip it. Right, so those are our two options. So we can say two options. 1, rob house I. 2, don't rob house I. Okay, and then if we do rob house I, then that means our optimal solution at index I, so opt at I, will be the amount of money we can rob from house I. Right, so like if we're at index 2, then the amount of money that we can rob from index 2 or house 2 is 3. That's the amount of money we can get from this one house alone, right? So if that's the case, then we can get that from house I plus the amount of money we were able to get from houses up until 2 before I. 2 indices, I should say. Like that. So what I mean by this, also if I'm looking over here, I have a piece of paper because I kind of wrote out some of these notes on a piece of paper before I got started, so that I could solve it out and not struggle with it on camera in front of you guys. But basically, so at index 2, right, where we have this value of 3, if we do choose to rob this house, then the optimal, like opt at I mean, which is the maximum that we can get at index I, is going to be the amount that we get from this index, which is 3, plus the amount of money we were able to get from all previous houses up until 2 indices before I, because we can't do the adjacent one, so it so it basically it's like the optimal solution up until this index, right? Which is the maximum amount of money we were able to get up until this index, and then we skip this one and then take this one if we are choosing to rob house I. So the maximum amount we could get at this one is 1. Then the value of this is 3. So then the maximum, the optimal amount of money we can get from I equals 2, which again, remember opt at I denotes the maximum amount that can be robbed from houses 0 to I. So it's everything up until I, including I. Then that is 4. And that is actually the optimal case when I is 2. Just worked out like that coincidentally. So that, I need to write out the actual occurrence, but I almost forgot that part. So the recurrence is going to be, so opt at I, if we do rob this house I, is going to be the value of house I, so like the amount that we can get from it, which I will just, well, normally I would say like v sub I or something, but I guess in this case, because like they give us an array, so we can just say like nums at I, because that technically is denoting this value here. So we could just say nums at I plus opt of I minus 2, not 1, I minus 2, right? Because that would be 2 indices before I, which would be like this one if I is 2, right? So that's it for that. And then if we don't rob house I, then opt at I will denote, and let's think about what this means. So if we don't rob house I, then we are skipping over it, and so if we skip over it, then that means that the house right before it and the house right after it are totally fair game, right? We haven't gotten to the house after it yet, but but that means that this value, like the optimal amount of money we could get from this house, should not be any different than the amount of money we can get from this house, because it's just this house plus 0 because we didn't rob this house, right? So it's actually just the same as the one before it. So this will denote the amount of money, not denote, will be, I guess, the amount of money that we got right before getting to I. And then the recurrence for it, opt at I, is just going to be the same as opt of I minus 1. And that's pretty straightforward for this one, right? It's just the same as the amount of money we could get from the index right before. Okay, so then now we can kind of put this all together into one recurrence. And let me sort of separate this out so we can see it a bit more clearly. These comments are so long, guys. I'm sorry. Also, I hope this is making sense. I know it's a little bit confusing. It's honestly pretty confusing for me too, but I hope I'm doing an okay job of explaining it. But our recurrence is going to be, so for opt I, we just kind of put this together, right? So it's going to be the max, because we want to check both of these. Like, obviously, at every single step, we want to take the better of the two options. So, and again, our two options are either we rob house I or we don't rob house I. So at every single step, we're just taking whichever one will give us a better result. So that's going to be the max, because we want the maximum amount of money we can get. So we're going to take the max of this one and this one. So we just put it together. So nums at I plus opt of I minus 2 and opt of I minus 1. Why do I keep typing 1 here? That should be a 2. There. So this is our recurrence. And now we can sort of just put it together into the code. Because, like, this is really just, like, the main part that we were trying to get to before we start coding it. So now we can start by writing our base cases. So base cases, if nums.length is 0, return at 0, right? If nums.length equals 1, return nums at 0, because that means there's only one element, and we would just rob that and be done. Okay, and then we are going to create an array for our opt array that is going to be a new integer of the same size as nums, so nums.length. And then let me actually paste an example here. So okay, and then this is currently empty, but it has the same amount of elements as nums. Okay, like that. And then, So remember, opt is storing the maximum amount of money that we can get at each of these steps from like corresponding to this nums array, right? So at index 0, we want to fill it with just the first value, because if we take a look at our recurrence, right, we're accessing previous elements here, like I minus 2 and I minus 1. And at the first two indices, if we don't pre-fill the values and start from 2, then we're going to have an index out of bounds error, because we can't access the amount of money from a house that doesn't exist, right? So we need to initialize these first two values and then start it from 2. So we'll say opt at 0 equals nums at 0. And so that is going to set this to 1 in this case. And then opt at 1 is going to be equal to, not nums. So in this case, we want to take the max. Remember, opt at 1 is this. So we want to take math.max, and then we want to take the max of this and this, because that will give, like, we can't, remember, because we can't do both, so we need to take the one that will give us more. So nums at 0, nums at 1. And then if we take a look here, nums at 0 is 1, nums at 1 is 2, so we take 2 because that one's bigger. This will be filled with a 2 here. And then now we can start filling out the rest of our opt array. So for int I is 2, I is less than nums.length, I plus plus. And then we just kind of start filling out the values. So opt at I is going to be, and then we just can plug in our recurrence here, basically. This. So I know that's like not actually formatted syntactically correct, but let's fix that real quick. So this will be math.max. This will be a parenthesis. Can't forget the semicolon. And then this will be a square bracket because it's accessing elements in our opt array. Oops, what did I do? There we go. Yeah, that should be right. Okay, so then this, if we take a look, like, let's just walk through this real quick. So at I equals 2 will be here. Opt at I, which is 2, is going to be the max of, and let me actually just type out a comment so we can see. So opt at 2 will equal math.max of nums at 2 plus opt of 2 minus 2, comma opt 2 minus 1. Right? So 2 minus 2, that gives us 0. 2 minus 1, that gives us 1. Okay, and then nums at 2, what is that? That is 3. This gets replaced with 3. Opt at 0 is 1, so this gets replaced with 1. Opt at 1 is a 2, so this gets replaced with 2. 3 plus 1 is 4, so that's a 4. So the max between 4 and 2 is 4. So then we'll take a 4, and this is what, like, we're setting opt at 2 equal to that value, so this will become a 4. Okay, let's do this again, except for our next index. So opt of 3 now, because we'll be in the next iteration in the loop. 3 will be, and then we'll replace all these i's with 3's. Okay, 3 minus 2 gives us 1. 3 minus 1 gives us 2. So nums at 3 is 1. Opt at 1 is 2. Opt at 2 is 4. Oops. And then this simplifies to 3. So the max between 3 and 4 is 4. So we'll take 4, and then we'll set opt at 3 equal to 4. So that is the rest of this loop, and then we exit out because there's no more elements. And then lastly, this is our very last step. So remember what they wanted us to return. They want us to return the maximum amount of money we can rob tonight without alerting the police. So which element in our opt array is representing this maximum amount of money that we can rob tonight? Well, that's going to be the last element, because we propagated this array from the beginning, like from index 0 all the way to the end, right? Which is bottom up, I believe. So this last element will be storing the maximum amount of money total that we got along the way. So we can just go ahead and return that element. So we'll just return opt of nums.length minus 1. And that should be it. So let's test this out. Yay! Alright, so let's go over time and space complexity. Oh my god, guys, look at my comments. Let's go ahead and just put it here today. So time complexity, let's take a look. This is constant, so that's whatever. Constant. So constant. So it's really just this one loop, and we are looping through from I equals 2 all the way until n iterations, basically. So it's proportional to n, because, yeah. Anyway, so then this is going to be O of n, because the inside of this is constant. So our time complexity is going to be O of n, where n is number of houses we are visiting, I guess. It's basically just the number of elements that are in this nums array, but it's also like the number of houses, because that's what that technically represents. So our space complexity, let's take a look at what data structures we have here. So got nothing here. We have this opt array and nothing down here. So this opt array we initialize to nums.length. So this is also proportional to n. So this is going to be O of n as well. And n is representing the same thing in this case, because it's based on the same array. So that is it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye!